So now we're moving on to a new set of trigonometric identities. And we're going to use the summation identities to derive this new set called the double angle identities. And this is a pretty good hint. I personally don't generally memorize the double angle identities. I don't need to. I just reinvent them anytime I need them using the summation identities. And I'll give you an example of how that works. What I've written here is just the summation identity, right? Signs can't change signs. Sine of a plus b is really close to what I want, sine of 2 omega. The difference is 2 omega is omega plus omega, right? So think about it this way. That's an equal sign. 2 omega equals omega plus omega, right? So I can use the summation identity with two angles that are equal to each other. Let's go ahead and do that. Okay, so I'm going to say sine of a plus a, right? And now we plug in a everywhere we see a b in this thing. So that's going to be sine a cos a plus cos a sine a. And now I just want to point out that, well, sine times cos is the same as cos times sine, right? There's a commutative property of multiplication, which means we can rewrite this as sine a cos a plus sine a cos a, right? See what I just did right there? Now, that's useful because we can combine like terms. And this is what I get in the end. Sine of 2a equals, I have two terms that are each sine times cosine. So 2 sine a cos a. And there is your general double angle identity for sines. Now with cosines, we're going to do something similar. I'm going to change all those b's to a's and pretend I'm adding two angles that are equal to each other. Okay, so what do we get? Let's see, cosine a instead of b minus sine a sine a. Okay, so that equals, if you combine these terms, cosine times cosine is cosine squared. Sine times sine is sine squared. And that is your double angle identity for cosine. Okay, it's a little shorter than it was for sine. But there are several different versions of this one, so I want you to be comfortable with all three of them. If you remember the Pythagorean identity, what is cosine squared equal to? Think about that for a moment. Cosine squared of a is equal to 1 minus sine squared of a. So now I can rewrite the identity above as cosine of 2a equals 1 minus sine squared a minus sine squared a. And that means cosine of 2a is equal to 1 minus 2 sine squared a. Okay, and that is the second important form of the double angle identity for cosines. Now we can go through the exact same procedure, and I'm going to need just a little bit more room, so tangent, you're going to move. There we go. I'm going to go through the same procedure here, pointing out that if you look at this one right here, I can change sine squared into cosine squared, according to this Pythagorean identity. Sine squared of a equals 1 minus cosine squared of a. All right, so that means if we think about how this is going to all work together now, we say cosine of 2a equals, and I'm going back a bit on the page here, so let me just rewrite this thing again. Cosine squared minus sine squared, right? So now that means cosine squared minus 1 minus cosine squared. And we're going to have to distribute the minus sign through multiplication, and what you get in the end is this, 2 cosine squared a minus 1. That is cosine of 2a. So you see cosine of 2a has three forms, and each of them has its place and is actually very useful. Again, I don't memorize them, I just recreate them as I need them. Now this last one, tangent a plus b, is very easy. You just change all the b's to a's. Okay, so we get tangent of a plus a equals tangent a plus tangent a over 1 minus tan a times tan a. And if we simplify this a little bit, we get the following. Tangent of 2a equals 2 times tangent of A divided by 1 minus tangent squared of A. We don't use this one too much, honestly. I mean, you can, it's fine, but you can also just find tangent of 2A this way. Keep in mind, if you ever have sine of 2A and cosine of 2A, you basically have tangent of 2A already. Remember, tangent is just sine over cosine. So if you know sine and cosine for these other angles, you have a shortcut to get tangent. Whichever way you want to use it is fine, obviously. But these are your double angle identities. Okay, we got a tangent one. We have 3 actually for cosines. Should be comfortable with all of them. And this is the one for sines.